Hello everyone. In this video I'm going to show how a firm can estimate elasticity from some actual price and quantity demanded data that it may have. So what I want you to do first is draw your attention to this little table that I have here. So each row represents a price point that a firm has chosen and the quantity demanded, so basically the number of units of product sold over that time period at that price. All right, so suppose when this firm was selling its commodity type product at only $2 a unit, it sold 1,450 units. Now, suppose in the past, during a different time period, the firm raised its price to $2.99 and it sold 1,398 units of the product. And then maybe there was a time the firm tried to discount its price a bit down to 149, and the firm sold 1,502 units of its product. Okay, so to work this, you would have to have that actual data and have recorded it. Okay, now what you have to do next is figure out what we call the slope and the intercept of what we call a linear regression equations. Let me just put that term down here, linear. This is all part of what we call linear regression. You do not have to know the advanced statistics for our class. Okay, so what you do in Excel is you set up a formula. Let me show you from scratch here. You do equal slope. Okay, so just literally the word slope. Then you type left parentheses. And notice how it's telling you it wants the y variables. Okay, the y variable in this case is quantity demanded because the y is influenced by the x. The x causes the change in y, or so we think. So in this case, the price is influencing the quantity demanded. That makes the quantity demanded the y, and the price the x. Okay, so what you would do is you would highlight one. This is just assuming not everyone has Excel skills. So you click one cell, hold your mouse, drag down to select all the Y's, okay, all the data, then click comma, and then it wants the known X's. So I'm going to, in the same order, I'm going to click and hold one of my price points, drag down, release your mouse, and close the parentheses. And if you enter on that, it gives you a slope of a line equation that relates the quantity demanded to the price. Now, to run a linear equation, you might remember from high school that you also need an intercept. Well, luckily, Excel has a function for that called intercept. So again, let me show you how to do that if you're new to Excel. You would type equals the word intercept, left parentheses, right? It wants the y's first, so the y's are the quantity demanded, comma, the x's are the prices. Okay, so again, exactly like you did with the slope formula, and it gives you what we call the intercept. All right, now the next thing that you do is you format your slope and intercept into a linear equation. And if you guys remember from high school, that might have been a long time ago, or maybe not so long ago, you might remember the phrase y equals mx plus b. You never thought you would use that again, right? Well, the y is on the left-hand side. The y's, remember, is the quantity demanded. So what you do is you say, okay, you have an intercept term, okay, which is the 1594. So I just hand typed it, or you could also have cell reference that, okay, plus, and then what you do is you add your slope times the price. Okay, so the slope again, I just brought down from our slope formula that we came up with using the power of Excel. So this thing right here, let me zoom out a little bit. So this row right here, we often just call it the demand equation. That's what you're going to use to forecast how a different price might affect demand for your product. Okay, let me show you an example. So suppose right now you're pricing this product at $2.29 per unit, and your manager comes to you and says, should we raise that price to $2.49 based on the demand equation above? So remember, this is the demand equation. Okay, so we have a QD at $2.29. Now, if I knew what my quantity demanded exactly was going to be, I could just use that. But because I might not know that for sure, what I'm going to do is I'm going to run the demand equation, and I'm going to input the $2.29 price as my variable right here. So take a look at what you do in Excel. And again, let me show you from scratch. It's going to be the easiest way. You type an equal, okay? And now you're going to follow the format of the demand equation. So first I'm going to click what we call a cell reference onto my intercept. Then I'm literally going to type plus, okay? I'm then going to click and highlight my slope. And because I literally want to follow the pattern of the demand equation, I'm going to then multiply next, which on my Windows device is a Shift 8, the asterisk, okay? And now I have to then type in or cell reference the price. So since I don't have another cell for that, I'm going to type in 2.29. So this is going to have Excel run the demand equation at a price of $2.29. You can also do this in a calculator. Okay. Now suppose I raise price to $2.49. I don't know exactly what my QD is going to be, so I'm using the demand equation as a forecasting tool. Okay, so I'm going to rerun then the demand equation again. So intercept plus slope times your new price of $2.49. So this firm is going to predict a decline in quantity to about 1427.87. And in real life, if you have whole number units for your product, you would just round those. Now you might think you're done. We want to figure out, is it a good idea? Okay. The slope is not literally exactly the same as an elasticity, because if you remember the elasticity, it's the percent change. So we're almost done. I know this is kind of a little bit challenging. What you need to do is figure out the percent change in QD as you raise that price from 229 to 249. So again, let's practice with that. A percent change is always the new value minus the prior value divided by the prior value. Okay, so let me again show you how to do that in Excel. I'm going to type equals, left parentheses, new, that's my new quantity, my forecasted quantity, minus my expected quantity at 229, that's my prior price, that's my current price. And I'm then going to divide that by the current price, or sorry, the current quantity, 1441, and that will give me a percent decline of 0.93%. Now to run elasticity, I need the percent change in price as well. New minus prior divided by prior. So my new price would be $2.49 if I were to implement that, minus the $2.29 current price divided by the $2.29 current price. And that represents a price increase of 8.7%. Now we're almost done. What's the elasticity there? Remember, guys, the elasticity is simply the percent change in QD divided by the percent change in price. So in Excel, and again, let me show everyone how to do this. You would type equals percent change in QD, just literally click and highlight that cell. Then click the /, that's your divide by, and then click on the percent change in price cell. All right, minus 0.11. So now we can kind of bring everything together that we're learning. Minus 0.11 you want to recognize as inelastic demand. It's very close to zero. So what's the rule of thumb? When you have inelastic demand, a price increase is generally going to be the smart play because it's going to increase revenue. So if this firm was primarily focused on increasing revenue, it would strongly consider going ahead and increasing price to $2.49. If you had different numbers derived again from this actual data, maybe your elasticity came out to be minus 1.11, okay, then you would have elastic demand and it would not be a good idea to go ahead and raise your price. So this is just a nice way to show how all these concepts come together when a firm has some actual data and is trying to implement a good pricing decision. And I will see everyone in the next video.